Find two positive numbers x and y such that x plus y is equal to 60 and xy cube is maximum. So we have one of a kind question till now compared to whatever we have done. This is a new question, new version. This is, say, a function f of x comma y, which is xy cube. Okay, I would like to call this as a constraint, and I would like to call this as something that has to be optimized. Right? So this is a constraint. If someone asks you, what is the maximum possible value for this? It's infinity by default. But if I tell, you know what, x plus y has to be adding up to a value which is 60, and x and y has to be a value that belongs to positive real numbers. So if this is so, what is the funda? So this would be the constraint, and this has to be optimized. Such a question, how do you handle? Well, as usual, we will try to find the optimum or the critical point of f of x by differentiating and all of that. So we're going to differentiate f of x comma y with respect to x. Since y is also a function of x, that is y, if I rearrange, will also be or can also be written as y is equal to 60 minus x. That is that it is a function of x. I can express y in terms of x. So I can differentiate f of x comma y with respect to x, and your differentiated expression will look like this. And we have seen this before. So we have the product rule. So we have this to be 1 into y cube into u into differentiation of y cube. So that is 3y square into dy by dx. This is as per the chain rule and product rule. So now we'll have to find the critical value of f of x Okay, so critical value of f of x is obtained by equating f prime of x comma y to 0 of the function f. It is f of x comma y actually. So basically this expression, so here I can see that y square is common, so I'm going to take it out. So we have this to be y plus 3x into dy by dx, and all of this should be equated to 0. Now from this I can talk of two cases wherein y square is equal to 0, which is not possible because y has to be positive number, right? And the other case would be y plus 3x into dy by dx to be equal to 0. Now how will we solve this? If we solve this, we are done. Well, let's go back to the constraint, right? So from this we can manipulate this. What we can do is we can substitute for y, right? Is it not? Just a second, I'm trying to draw this. So I can substitute y is equal to 60 minus x. But what about this? That's the question. How will we handle this? Yes, that too we have to go back to equation 1. I didn't call this as equation 1. Let me call it as equation 1. Okay. So what we'll do is we're going to differentiate 1 with respect to x. So differentiation of x is 1 itself. Then differentiation of y is dy by dx, and differentiation of a constant is 0. So from this, what can I tell? Dy by dx is equal to minus 1. So substituting y and y prime in, I'll call that as a. So this, I'll call this as a. So we have y plus 3x, sorry, not y plus, 60 minus x plus 3x into minus 1 is equal to 0. So a bit of simplification, 4x will be equal to 60. So x is equal to 15. So this is only critical point which makes sense. Therefore, y is equal to 45. This is from 1. And thus, the question is, we have to find the maximum value or where the maximum value is. Find two positive number such that this and this is maximum. Okay, we just have to find x and y. Therefore, xy cube will be maximum for x is equal to 15 and y is equal to 45. That would be your answer. So I would like to mention that there are other ways of doing this. Quite a few other ways, a lot of ways to be honest. So one simplest most would be something like you guys are substituting, right? In place of x, we can substitute 60 minus y and all of that. That's optimal. I mean, that's good that we are able to do that and it looks to be simpler. I can promise you this methodology, if you understand, a lot of questions in the future will become very simple. If you go with substitution, it will be a lot complicated. You can look at it. In place of x, if I substitute 60 minus y, or in place of y, if I substitute 60 minus x, that will be very complicated. While this, the only bit that is extra is we are deriving information from 1 later on, not initially. We are substituting, but we are substituting in a scenario wherein it's much simpler to handle. And this would help in a lot of questions. The calculation becomes very simple. So that is my advice. So please go with this methodology. It's not too hard. We have seen such expressions. We have seen such expression. It's a simple derivative. So it's not at all complicated. It just dependent on x and y, these functions. And you can differentiate with respect to one of it. So, and other will be changing with respect to that variable, so on and so forth. So don't make it too complicated. Think straight. It's very clear. You have done such questions. Don't panic. Okay. Yeah. So you can copy. We'll do a few more questions. You will feel better.